Okay, question number 12. From the figure, calculate the length of BC, correct? Two, three significant figures. Okay, so we have to calculate the length from point B to point C. Definitely, I cannot find out the length of BC all at once. I'll have to divide BC into two parts. I can find out the length of BC if I say okay, BC will be equals to the distance from B to X plus distance from X to C. I can find out the length of BC if I know the length of BX and the length of XC. So first of all, I'll need to figure out how to calculate the length of BX and XC. As soon as I have these two lengths, I'll be able to calculate BC. So if you look at BX only, BX is the side of a right angle triangle AXB. And in AXB, I have two sides known. One of them, let's say, is the opposite, which is 4. This is opposite, let's say, this is opposite. And I have this, which is, let's say, hypotenuse. So I can use the Pythagoras theorem to find out the length of BX. According to Pythagoras theorem, hypotenuse, which is 15, hypotenuse square equals to base square, let's say, which is BX square, plus perpendicular or opposite, which is 4. 15 square is 225 is equals to bx square plus 4 square is 16. In order to find out the value of bx square, I'll remove this 16 from this side and bring it on the other side. This will be 225 minus 16 is equals to bx square. So bx square is going to be 225 minus 16, which is 209. To find out the value of bx, I'll take a square root on both the sides, and square root of 209 is going to be equal to 14.45. Do not forget that I have to give answer up to three significant figures. So I'll say 14.45 will be rounded off to 14.5 centimeter. This is the length of part 1, which is bx. Now I'll move and find out xc. Again, xc is the length of a side of a right angle triangle AXC, in which this will again be taken as the opposite. 5 will now be taken as the hypotenuse, and I'll apply Pythagoras theorem, according to which 5 square is equals to base square, let's say xc square, plus opposite square, which is 4 square. 5 square is going to be 25. Xc square will definitely remain xc. 4 square is 16. I'll move 16 to the other side. This will be 25 minus 16 is equals to xc square. 25 minus 16 becomes 9. So xc square is equal to 9. I'll take a square root on both the sides. This square will cancel. Square root xc. The square root of 9 is going to be 3 centimeter. Now that I have bx and xc, I'll be able to calculate bc. bc is equal to 14.5 plus 3. So finally, BC is going to be 14.5 plus 3, which is 17.5 centimeter. This is part A. Now let's see. We have to calculate angle BAX. Acha. Now, while doing part B, this is the angle BAX. I have this side, I have the length of this side. I have the length of this side, and I also have the length of this side. And we can find out the angle of a right angle triangle with the help of the trigonometric ratio. Okay. I can use maybe sine theta, cos theta, and tangent theta, any one of them, because I know all the three lengths. So let's say I'll use cos theta. Cos theta is equal to adjacent upon hypotenuse. The angle that we are trying to find out is BAX. So I'll say cos BAX equals to adjacent according to this angle is going to be 4. Okay. Do remember that adjacent is the shorter side along adjacent is the shorter side adjacent to the angle under consideration. Okay. So uh, adjacent is going to be 4 and hypotenuse is again 15. Since I have to find out angle BAX, so I'll have to remove that cos cos will move to the right hand side and it will become cos inverse of 4 upon 15. We can find out the cos inverse of 4 upon 15 with the help of the calculator. So that is going to be 74.53. So BAX is equals to 74.53. Since I have to mention answer up to 3 significant figures, so I'll say 74.5. This is question number 12, and there are no more parts in this question, so I'll leave it here. Yes, that is it. This is our question number 12. Both the parts of question number 12 have been solved, and we will continue our discussion of the next question of the worksheet in the next video. So that's it. Thank you.